right. I think we're getting started. Hi, everyone. My name is Julien. I work with Confluent. And today, I promise you that we'll start a little bit after the Big Bang and we'll finish around 2024. It's nice to have you here. Thank you for using your lunch breaks to be with me today. We are Confluent. We also have a booth, so any side conversation we can still take for during the remainder of Devox. So, data streaming, right? So we'll talk a little bit about data streaming and the fact that what is data streaming and what are we doing here? We'll talk a little bit about Apache Kafka. Show of hands for who knows Apache Kafka. Okay, so you're in the right place. We'll talk a little bit about Apache Flink, about Apache Iceberg. And yes, we are Confluent, so we do have something to sell. So let's bring the disclaimer in there, and so it's out of the way for now. Let's not show this slide for now. So I said after the Big Bang and before 2024. So let's talk about events. So today we're going to talk about events and how those events were being produced. So we're not really talking about inventing the fire or the first fire when it was started. If for the Kafka aficionados out there, you may remember that sticker that we had that the three big inventions of human beings were the fire and the wheel and Kafka. But we're not going to talk about that today. We're going to talk about the moment when events started being captured by IT systems, databases, SaaS solutions. Now we have IoT devices. We have a lot of ways to generate data, and those are all events that are captured somewhere. And what happened in the past 50, 60 years is those events kind of needed to go from one place to another. And then it happened again. And then we had operationals that had to send this data back to analytical people. And now we have Gen AI and all that stuff that needs to kind of re-inject data into operational systems so it responds faster. And well, it created kind of a mess. We have a lot of point-to-point. We have ETLs, we have message queues. And that's kind of when Kafka was kind of created and became a lot of the backbone of the operational systems today in order to propagate events from one place to another, but not just from one place, but actually from one place to many others, and the list could go on. So we've created a little bit of this brittle architecture, and Kafka is solving a lot of that. That's kind of the situation when a lot of companies have standardized on Kafka to put at the back of their IT systems. So you may know all of your mobile apps. If there's a real-time experience in your mobile apps, it's usually powered by Kafka. So say you have two microservices, they're connected one way or another because they have loose needed requirements to get data from one place to another. That's usually powered by Kafka. So if you order an Uber, there's a matching service, there's a driver service, there's a billing service, all of that gets data through Kafka. So that whole architecture has become quite simple. But it all comes down to this, right? The data mess becomes developer pain. And we are having trouble kind of moving this data around. And we can no longer limit ourselves to operational applications. Analytical applications have to be also a very big part of our focus. That's I think, general considerations. We've had data lakes in Hadoop 10, 15 years ago. We used to drop a lot of data in Hadoop. That didn't quite pay off because the data kind of ended just being dumped there and never being used. We have the opportunity of the cloud where now storage kind of costs nothing. But what are we going to do with this compute in the cloud now that all this data comes for free? There's this whole difficulty, right? So we also have that other big data problem, which is how do we map the operational estate and the analytical estate? Not to mention that it's no longer just going to the right, going to the analytical. We have a lot of data that's coming from the analytical systems that needs to come back to operational systems for real-time analytics application, but also all the Gen AI type of world of use cases, if that makes sense. So essentially, we are trying to move from this data mess to a notion of data products. So data products where the producer becomes the owner of the data. We have data that's available, that's discoverable, that's governed, that's secure, That's available pretty much anywhere. It could be used by our internal colleagues in other departments, but it could be used by partners in a lot of time, not to mention that it still needs to be secure, anonymized, and all that stuff. So we are moving towards the data products, but we've been thinking about the data products in the analytical world. And I think that's when, if I've done a good job today, if I kind of challenge that, are analytical products, are data products really just in the analytical world? Is a data mesh a data warehouse? Those kind of challenging thoughts that I'll leave you with today. I don't expect to provide you a full answer, because if there was a magic wand for this, we would not be here, probably not any of us, right? So let's talk a little bit about event-driven architecture. Does that sound familiar, that term, by show of hands? Okay, good, thank you. So event-driven architecture is the notion that instead of using the data stale and stored in databases, we're going to start using the data as those events are being produced, and we're going to move this data and react to events much faster than we used to. It doesn't mean that we're not going to store this data. It doesn't mean that we won't be able to query it, but we want to move to a world where those events are the way that our enterprise is functioning. So behind this usually sits Kafka. So that's the big divide, right? That's the equation we're trying to solve today. To the left, we have our operational estate. We certainly have a lot of data that's being produced. Let's imagine that this data, we have the capacity to put it in Kafka. The good news for you is that it's most likely possible to connect pretty much any of your system and put that data into Kafka topics. And to the right, we have those data products. And the idea is how do we move from data products in the analytical space to universal data products? And let's imagine, fast forward, I think when, I wouldn't say we're in 2024 now, maybe we're a little bit into the future. I think certainly a lot of companies have that already, but it's certainly kind of very premature as a thought process to have a universal data product where the data is in Kafka, Kafka is storing the data, and it's already a kind of a data product. And the value of this is the data is real time, right? So it's near real time or as real time as it needs to be, based on, of course, the use case. And the same thing for the storage. We can store as much data as we want because it depends on the use case. But the data has a schema, and the data is a data product. So it follows the data mesh principle because it has an owner, and the person responsible for reading this data properly is not the consumer. The responsibility comes back to the producer of the data. And it's powered by data streaming. So that's where that data streaming kind of sits. And we'll talk a little bit about how that works for the Confluent vision. But of course, that can integrate into many of the players that are in here. So the Google products, the Microsoft products, Oracle databases, Snowflakes, things like that. There's connectors everywhere for Kafka. So that means that for us, it's very easy to capture the data and kind of make sense of this vision, if that makes sense. So we'll talk a little bit about those four things, and I hope I'm not going to run out of time. So we have capability to stream. So stream, the keyword is Kafka. Kafka is the power of those modern applications that are powered by events. It's Kafka. The second is connect, because if you have a very powerful distributed system that scales really well and that's in the cloud, but you can't put data into it, we have a problem. So we need to be able to get the data in. So Kafka Connect, anyone uses that framework today? Okay, way less. So Kafka Connect is a framework to build connectors, and the good news is that so many of those connectors are already existing today. And it's not limited to connectors. You can do in-dev things connected to Kafka because we have drivers for pretty much any technology, Java being the kind of the core one. So I think it's kind of relevant for DevOps. Third thing is govern. We need to put the data, but I think we've spent a lot of years using Kafka as a pub sub or just as a dumb pipe, and the requirements we see evolving as those requirements are becoming more critical, the applications are becoming more critical, is where do I do the governance? Do I do it before and after, or do I do it actually in the data streaming? The answer is, yeah, it really depends on how mature organizations are with this stuff, but that's kind of the idea. And last but not least, Kafka streams. Anyone? Right. Good. So Kafka Streams, it's a framework to move data, transform data as it is processed by topics, and do that on the fly, and transform the data as it is being produced. We'll talk a little bit about Flink as an alternative today. Flink, anyone? All right, that's what I was expecting. It's a much newer framework, so it's interesting. I would say Flink is to stream processing what Spark is and has been to batch processing, if that makes sense. I'm sure I'm going to make some people upset by saying this, but it's sort of like that in terms of the reason why it was invented. And so the idea is really just capture the data, put it in there, transform it, and get those data products with data that is as fresh as possible and as high value as possible. And I would say the big, again, provocative statement I'm going to make is when you put data into Kafka and you have like one consumer in mind, if the data is high quality and it's discoverable, you're going to get many more consumers than you had anticipated, which provocatively may not have happened in the Hadoop vision of the world, sort of. I'm sorry if I'm making people upset. So that's what we do, right? At Confluent, we do that. There's Kafka as a kind of the engine, the thing that we power. And we do connect, process, stream, govern, publish that into data product, and reconnect to the things that need the data. And I'll get into a little bit of details, keeping in mind of time, but into those 4 kind of stream, connect, govern, process. And that will be the idea for today. And I'll do a little bit of future projection with how we bridge to the analytical, which I think is the most interesting from me as a technologist. So Apache Kafka is those 4 things. Why does it matter? It's real-time messaging, but it's real-time messaging that doesn't break because it's distributed, and it scales because if you just have more throughput to get, you would just add a new broker, and the throughput automatically evolves like that. It's as simple. In the cloud, we actually manage that. And it's just brokers that massively distribute the load of many customers in a multi-tenant architecture. It stores the data, which I think is interesting because it's not only about real time. Sometimes we do need to retrieve the data and its history to be able to reconstruct state. And sometimes we don't always know with which consumers we're gonna start. So actually, storage is interesting, especially in the context of data products, because some objects may not have. We may just need some sort of a view of those objects. The third, data integration. The key here is Kafka Connect framework, and data correlation here is Kafka streams, and in the future that Flink that we're going to talk about a little bit today. Just updates on Kafka. If you haven't heard of Kafka for a while, it's still powering pretty much any event-driven application on the planet. There are some nascent alternatives that you might see and might get interested in, and we're happy to talk to you about those. But it's the standard. It works, it's supported, there's a lot of expertise on the market, and I could go on. There's meetups, there's companies behind it, so it's a very vibrant ecosystem. And it may go away, but I don't think it's going away for the next few years, right? And there's a lot of innovation brought to Kafka. You may have heard about tiered storage, for example, that's been added to the Kafka open source. There's been a lot of work on zookeeper removal. That debt was so big that actually it took a lot of time to remove zookeeper. I'm hearing some people smile. Well, it's behind us now. So if you are starting with a new Kafka cluster, you won't need zookeeper, which is, I think, very good news. So for the first 2 years of zookeeper removal, you still kind of needed it for the old clusters, and you couldn't migrate, but now you can. So that's the good news. If you have some Kafka that's still using zookeeper, you are entitled to move away from zookeeper. And it's been replaced by Craft. And there's a few other things that have been happening on the community. Maybe talk about what's next. We have queues for Kafka that cover a few use cases that message queuing we're doing really well that Kafka doesn't do. That's coming. So it's going to be like a virtual share groups of Kafka consumers. And then there's two-phase commit, things like that. Future ideas, just stay tuned to the community. You can always watch Kafka Summit and current keynotes to get a sense of what we're working on as a community of Kafka people. And let's talk a little bit about the kind of the cloud thing of Kafka, because putting Kafka in the cloud is not just putting Kafka in the cloud. It's doing all those things. It's making something that customers do not have to manage brokers anymore. They don't have to size brokers. They don't have to manage craft now. Zookeeper is gone. They don't have to manage things or processes on JVMs. They don't have to manage schema registry, REST proxy, all these components that were quite difficult, and you had to kind of scale independently and make sure that they didn't break and make sure that you have HA. So it's all about that. Transform that into a cloud service. And make it elastic, so it's in the end just you're using a certain type of environment and it scales for you. Of course, you can have dedicated capacity for when you have enough use cases, so you do the multi-tenancy for your internal clients. So I think that's the general kind of where we put the balance. And it's compute and storage decoupling, I think, is the most interesting, because it just works for you. So if you are using something like infinite storage or very long-term storage, in the back end we just use an object store. So it's a very long-term storage at a very low price point. So all the things that we could do in a data lake, we actually already do on Confluent Cloud. Again, provocative statements. It's lunchtime. And then it's just networking and global replication. It works multi-AZ by default in any of the 3 cloud providers, Azure, GCP, AWS, and it works for you in that sense. Which, by the way, there's a lot of functionality in there that's available either on the Kafka ecosystem, but you have to manage them yourselves, or it's been developed specifically for what we call Confluent Cloud, and it's been called Kora. So Kora is the kind of the Kafka engine for the cloud, and we as Confluent, we are behind this. So we've been recognized on the market so if you want to nerd it out a little bit, there's a paper that's been produced on how we made Kora and how we made the multi-tenant architecture with a kind of a serverless first approach to making data streaming real. Works a little bit like that. I'm not going to comment into every single details, but there's the things we hear a lot is tenant segregation, quota limitation, and then there's very high-end software metering so that we can charge you based on what you use and not more. And there's also some mechanisms so that you can use a certain number of compute units based on your needs, and if the needs decrease, we actually decrease the number of compute units you're using. That's the general idea, and in the backend for storage, it uses object store. So the Kafka segments, when they're finished, actually, we age them in the object storage based on how much they're being used or not. We tend to age them earlier rather than later for the cost efficiency purpose of our solution. This is compared to Kafka. I think we could debate that a lot of customers have done those optimizations themselves because they have very, very advanced knowledge on Kafka. A lot of Apache Kafka users or companies do have teams of 30 working on Kafka because they've put it everywhere. So arguably, they could do that themselves. Well, in Confluent Cloud, you don't really have to do it yourself because it's actually done. So fast, because end-to-end latency, P99, those things, it's already taken care of in terms of optimizing, balancing, and things like that. Elastic means you provide like a certain, I want a maximum of X compute unit to make sure that I don't go over a certain cost. But actually, if you say 10 and you only need 2, you'll use 2, if that makes sense. And resilient, that's all talking about the SLAs, because we have the best SLA on the market because we are Confluent and we also have a thing to say or two about the Kafka itself as a component. Cost effective is highly debatable, but usually it really depends how you use today the Kafka ecosystem. What we see a lot is that it's usually under-optimized, oversized if you do it yourself because you want to decrease your risks. So if you put it on the cloud and we do that for you, there's a certain equation that can be interesting. That's just an example of the the P99, comparing it between Kafka and Confluent Cloud. All right, and the thing you'll see is those things, right? You'll see just environments, and you'll decide to use a certain environment. Whether you are the biggest requirement is how much do I need to scale? What SLA do I need? And do I need private connectivity towards my cloud provider? It is a SaaS solution, like you put your own data into it, but it's a SaaS solution. And so enterprise and dedicated for like production type environment with private connectivity. And the things on the left are more for like non-production environment, development environment. And to start small, so if you are a developer and you want to just put try a few tests on Apache Kafka, it's very, very easy to do. And you just manage the topics, we manage the cluster. And it's literally starting in seconds. And that's what we've been trying to do, right? Especially with enterprise. Enterprise are very scalable environments that we will manage automatically the number of CKUs for you. You just tell us a maximum, and we'll scale you between 5 to 10 to 0, depending on how much you need. It actually scales to 0, which arguably might not be necessary, because if you don't have data at all, then it might scale to 0, but it actually does scale to 0. And dedicated is really just when you have that maturity, when you have enough applications that you do the multi-tenancy for your internal or external customers. And so that's the debate between over-provision versus outages, right? So enterprise has that capacity to scale you as much as you need, but never being over-provision, which arguably with dedicated, you might end up being over-provisioned. So that's kind of the trick, but I think we didn't invent that trick. That's a very cloud-native type of consideration. And yeah, that's what we've been doing. And so it scales in a few, I wouldn't say seconds, but it reacts quite fast to the number of limiting factors it needs, and it just adds compute. The compute has already been provisioned for other customers, so it's not a need of, there's no warm-up time, if that makes sense. So interesting, that's what we've been working on the stream part. On the connect, I think I'll be brief on connect, is connectors, right? So we have connectors to everything. Happy to talk in the details, but I think connectors above just a single connector help our customers or our Kafka users to bring patterns towards how I integrate to my events, because events is a conceptual type, but it's very hard to make it a standard depending on what you're connecting to. Am I connecting to APIs? Am I connecting to databases? Am I connecting to SaaS solutions? And the considerations for that are going to be very different depending on what I connect to. So I think JDBC, CDC type patterns for databases are popular. Anything like SaaS solution will generally integrate as like a REST API. Some of them, many of them actually now have Kafka connectors, which is always a nice way to make it even more real time. We could debate on the percentage of SaaS solutions because there's so many SaaS solutions. Databases, but databases, the interesting bit is it does integrate both ways, right? You need to write into them to read from them, so CDC, but also JDBC, but also if you're connecting to a NoSQL, there's usually a connector for that. SAP, anyone? Okay, well, there's many ways to connect to SAP. We'll talk. I have one slide on SAP specifically, so that you know that it's existing for your enterprises. Yeah, pretty much that's it in terms of the connectors. Something up about the connectors is you can manage them yourselves. There's a small Kafka Connect framework. There are connectors that are not leveraging the Kafka Connect framework, but as a developer, the big benefit for a Kafka Connect enabled developer connector is that it's already taking care of a lot of the boilerplate code. It's already in there. That means that there's a lot of Kafka Connect enabled connectors on the market. So they're Java-based, and the idea is you can develop one yourself for some system that you might need to do that. So you can just use instead of using the producer and consumer API of Kafka, you can use the Kafka Connect framework, which is an accelerator. Or you can use one of the connectors that already exist. So most of the connectors on this slide are using the Kafka Connect framework. And those connectors are also available, fully managed on Confluent Cloud. In that case, we actually take care of the workers, the Kafka Connect cluster for you, and that HA bit that is sometimes hard to get to. And I think that's it for connectors. Something happening on the SAP ecosystem. SAP is opening up their ecosystem in a different way with Clean Core and all that stuff. So you may have heard about that, but there's a big solution called DataSphere that's on top of BTP. So we are one of the few selected partners where they'll be able to write natively into Kafka and to Confluent Cloud actually. Right now it works one way, so SAP to Confluent Cloud, but it's going to also in a few months work both ways. So from business objects in SAP directly into topics in Kafka. More to come. If you do want to address any of those topics, we can always take it at the booth afterwards, right? Right. So govern. Let's talk about govern. I think that's the most boring part, but it's contentious, right? We want to do innovation. We want to make this data available. We want to make it in the cloud. We want to bridge to cloud. We want to connect to cloud. We want to do everything cloud native. But then, how do we do that in a secure fashion? So I think a lot about compliance is all about what partner you select to put the data in. So I think for that, you need to have a partner that's solid, like Snowflake is one, MongoDB is one, Confluent is one. So that's a big, usually like a kind of the basis for everything. And then there's functionality. So on top of that, for developers, for users, there's a lot of functionality that exists already in the cloud. For those of you who know the schema registry, I think that's the foundational layer of all we do in governance. And we've added a bunch of stuff in Confluent Cloud. And the idea is shifting it to the left. Don't leave it to the consumers to deal with schema changes or data changes, new fields, unit translation, things like that. It should actually be the role of the producers, because that's how we think in data products. And because the earlier we do it, the least time we have to do it again and again and again. So that's kind of the idea. We built 3 things: stream quality, which in Java kind of looks like that. So it's just a matter of making those data contracts back to life. One of the very specific things about Kafka is it's decoupled. Storage decoupled from compute, but also producers and consumers don't even know about each other. We just read a topic, right? We write into a topic. But this is what links them. This is how they're connected, because they have a schema. And the schema is producer-owned, if that makes sense. The data needs to become discoverable with a catalog, so technical metadata, business metadata, data, fields, PII, things like that, all searchable and all available to all the people who kind of need to get to this information. So data discovery is important, and I need to get to the core of this data. From topics, schemas, connectors, all of that, and get access with a number of tools, the UI being one, but of course that's just one. And connecting those 2 pieces together, seeing who inputs the data, seeing who consumes the data, seeing what's happening to the data. Do I have a Kafka Streams application? Do I have connectors? Do I have a join in a Flink task? Things like that, and it has to work for me. Looks like that, but it's what we call lineage. And I think that's a precondition for a universal data product. Obviously, the data has to go through Kafka at some point. So again, controversial. I'm happy to debate afterwards. The point is not to debate with an audience at this stage. Stream governance, Confluent Cloud. You could do it yourself with schema registry, but actually this is just a service that's available with 100 schemas in Confluent Cloud that you can leverage. Again, govern your Kafka topics, not something else. That would be weird from my end. Last but not least, let's talk about processing. So you may have known about Kafka Streams. Kafka Streams is much like a vibrant ecosystem. There's a lot of innovation still happening. Considering that some of you already know it, Kafka Streams is a Java-based framework that's available for Kafka, to Kafka, kind of a production to consumption message. So you take a data in a Kafka topic, you do something with it, and we republish this in another topic. So it could be a join, it could be data enrichment, it could be filtering, it could be renaming things. So that's not going away. But today I'm going to talk a little bit about, so first, that's the stream processing. And I'm going to talk a little bit about shift left, and I'm going to do that in the next 5 minutes or so. What we've observed is Kafka has been used as a dump pipe. We've used Kafka to take a piece of data, propagate it, and then do some processing downstream, right? Do like an aggregation in MongoDB, do some sort of a view filtering in Snowflake. In a SaaS app, maybe we'll have to do some filtering, likely, actually. And we'll end up doing, if you think about the data product, that's kind of two contradictory visions of the world, because then you have a sort of a data product in those three places, and we do processing, but differently, or maybe we do the same. It's not really clear what we want to do. So the idea that we pull forward is just to do the processing upstream, to do it less times. And in the cloud, I think, sort of relevant because we don't really pay for storage anymore. Again, controversial statement, but we do pay for compute, right? So compute is expensive. So if you can do, even for a limited number of the processing, if you can do some part of the processing upstream, you're going to pay for less compute. That's the idea. Could be done with Kafka streams. We'll talk a little bit about Flink now, but it could be done either way, depending on requirements, whether you have Java developers or SQL developers, who is actually going to use this data. Is this data engineer, or is it more operational systems for the data is prepared by developers type of stuff, and we can debate about that. So Flink, again, I would say it's to stream processing what Spark is to batch processing. I know there's ways to do stream processing in Spark, but guess what? There's also ways to do batch processing in Flink. But what we've implemented with Flink, we have a bunch of committers of Flink who work with us alongside us at Confluent. We've put Flink and we made it as a cloud service, leveraging for now the highest level API, SQL API. The reason for that is really you can't break it with the SQL API because it's using the Flink optimizer. And you wouldn't be able to break our Flink, but you would be able to break your cost. So that's what we are doing at this stage. And as the release gets more mature, we're adding more stuff to it, like user-defined functions are being added to Flink in Confluent Cloud. And for any user that's using Flink Data Streams API, there's going to need to be a bit more patient to do that in Confluent Cloud. Because it's using a lower level API on something like that and putting it in the cloud and making managed service is quite a complex endeavor. We'll get there. And the reason why we chose Flink is we had that big of a missing link in our Confluent Cloud, and we saw that the pattern of adoption of Flink and Kafka was very similar, just a few years apart. So we chose Flink and we integrated it to Confluent Cloud. And we use Kafka for the storage because we have Kafka. So we used Kafka in, Kafka out, and those two are linked by a SQL query. And it can scale to any use cases like pipelines, applications. AI, there's going to be native integrations into Flink with things like the LLMs of the market, OpenAI and such. So that's kind of where we're going with this. And to make, and it can obviously, for the Gen AI type use cases, integrate with a vector embedding service directly. But of course, there's also going to be those type of direct connections to the vector stores of the market because those connectors already exist. So let's talk about stream processing and data products as a final thing. How do we get this data from operational to analytical now? In 6 minutes, I'm not going to solve this today, but you'll get the idea, hopefully. We have this. Well, let's just fast forward a little bit and imagine that all the data that's relevant, all the events that we capture are in Kafka in some way. I know that's a stretch. Sometimes it might just be the most important events. It might not. It might just be transactions if you're a bank. It might just be orders if you're a retailer, things like that. But let's have that Kafka is the open standard for streaming events, which is absolutely true. I'll take debates about this later. But analytical estate has a very different ecosystem, which today is based on S3 and tables, right? So Parquet files turn into S3 and then read by the Snowflakes and the Databricks of the world, but also anything like Starburst or solutions like that can read this data. There's a consensus on the market. Maybe it's probably just forming at the minute because object storage are 10, 15 years old, so it's not that old. But Iceberg is becoming an emerging standard. Databricks acquired a company with a bunch of Iceberg developers, plus Snowflake is already on Iceberg. I think maybe it's a play on words. I wouldn't know. But it's an emerging standard for OpenTable that you can then leverage for your analytical queries in the cloud and to make sense of those kind of compute-first analytical use cases, or I would say the new data lake. And what's the bridge, right? So if you are a data engineer and you want data that's in operational systems and you want to take this data, make it into tables, and you need to do like a few things with it, extract it with an ETL, and then turn it into something else, maybe modify it. There's a lot of things that could be done in processing, but there's also a lot of actually just turning a stream into a table, if that makes sense. Well, it's actually oversimplified here because there's a lot of steps that could go into this stuff. And what we've been working on at Confluent is unifying those two worlds, not to solve all the problems of the world, but certainly to be helping in that area, and to make Kafka topic data directly available as a kind of a REST endpoint of Iceberg data. And we take care of modifying the data. We take care of making it Iceberg compatible. We take care of Parquet files. And we do that because the data is already in object storage in Confluent Cloud. So we already have that data. We already have it in that format. The only thing left to do is turning streams into tables. So it's a little bit of an operation like this. Not trivial, there's going to be a lot of things, but the idea is we'll take care of that, and you can just consume the data with an Iceberg REST API endpoint. And that's Tableflow. And that's probably going to be my last thing for today. So stream table, duality. I do hope you get interested and excited about this. And the idea is to leverage this and put Kafka data using standards on both sides, Kafka, Iceberg, and making that available through like a cloud-native service. And of course, potentially leveraging Flink, not just on Kafka, which is what we do today, but also leveraging it directly on Iceberg, but also, of course, opening up the Iceberg ecosystem to any of the solution that you might like and love today. That was my talk for today. Thank you for coming. It was nice to have a live audience. And yeah, thank you. If you are interested, there's some people who are much smarter than me who have talks tomorrow. They happen to be colleagues of mine, but they won't talk about Confluent, I promise. Thank you so much for coming. And if you don't mind, can I get a selfie where you get excited? That will wake you up. Hi. Thank you. It's going to be bad picture, but thank you so much for coming.
All systems are nominal. Initialize Genesis sequence.